Hey all! So for our next thing that we are learning, we are going to be learning inscribed angles this week. So this is going to be the last week of our circles unit. So this is the very last thing we're going to learn. So to start it off, we have these three circles with these three angles. What do we notice is different about them from what we have been learning? So remember, the things that we've learned have been how to find the sector area, the arc length, diameter, radius, circumference, and area. What about these three circles is different than the angles and the circles that we're used to? So some of the things you might have said was, one, well, what is the radius? What is the diameter? Only one of these angles, the one here, actually goes through the center. These two over here, they don't even go through the center. So that's nothing we've seen before with angles. Another thing, even though this doesn't go through the center, it's like, hey, you can still get me that arc length, which we don't know how to do because we can't set up our proportion because we have no idea what the radius is. We have no idea what the diameter is. So the big thing about inscribed angles is that we do not need a diameter or a radius to be able to find different angles and different arc lengths. There's another way to do it. So we're going to talk about what they look like and what they are. So inscribed angles. Inscribed, so scribed means written, and in means inside. So that means it's the angle inside the circle. That means it has to touch the perimeter of the circle to make the angle. So angle ACB, it touches here, here, and here. It touches all three points touch each side of the circle. Therefore, it's an inscribed angle. So angle ACB is an inscribed angle. And note how you write it. So because you won't be able, this is just for IXL and stuff. If you see something that says a little thing like that, that means angle. And ACB, you write it like you read it. So I start at A, I go to C, then I go to B. So you have to, if I wrote angle ABC, it would be talking about something totally different. So you got to write it as you trace it along. So that is an inscribed angle. Next, we have a central angle. Central angles go through the center of our circle. So if we go through the center, this marker's not working, which is always fun. It's going to go from here to here. It's going to stop at the origin. Then it's going to go here. So our central angle is angle AOB. So this is why writing it in order is so important, because these two angles look like they're the same, but they're two completely different angles. So that's the central angle always goes through the center and touches two outside points. Inscribed angle always touches 3 points on the perimeter. So I'm going to have you do a little discovery and try to see if you can figure out how to go from one to the other without me telling you. So we have these two circles here. This first circle here, which one's the inscribed angle? The angle ACB, that's 40 degrees, is our inscribed angle, which means angle AOB, which is 80 degrees, is our central angle. Also, notice how over here, it tells us the measure of arc AB, so this arc right here is 80 degrees. So we have a 40-degree angle, an 80-degree angle, and an 80-degree arc. Cool. Let's look at the second one. So first of all, which one is our central angle? Angle AOB is our central angle. Which one is our inscribed angle? Angle ACB is our inscribed angle. So what is the measure of the arc length? It's 100. So here we have the inscribed angle is 50, the central angle is 100, and the arc length is 100. So if you had to think to yourself, well, what if I only had my central angle? How could you find the inscribed angle? What mathematical thing could you do? You might have said, well, 50, that's half of 100, so I just divide by 2. Does that always work? Let's check over here. 80 divided by 100 is 40. Cool, we just figured something out. But what if we wanted to go the opposite direction? What if I had the inscribed angle and wanted to get the central angle? What do I have to do to that 40? Multiply by 2. 40 times 2 gives us 80. 50 times 2 gives us 100. So we know to go back and forth, we either multiply or divide by 2. The way that I like to think about it, if I forget how to do which one, you can see by looking at the circle that the central angle is bigger than the inscribed angle. It's fatter. That means if it's fatter and you want to go skinnier, you divide by 2. If it's skinnier and you want to go fatter, you multiply by 2. The very last thing we're going to talk about with inscribed angles is being able to find that arc length. Normally we had to set up that little table, we had to find the perimeter, do all this stuff. Well, here we can look at the angles and help us with that. So if our inscribed angle is 50 degrees and our central angle is 100, we notice our arc length is the same as our central angle. So as long as you can figure out your central angle, it's always going to be the same as your arc length. So arc AB, so note the arc has to start here and end here. So this arc is 100 degrees. If I was asking you, well, what about this red arc here? So the way that they would say this red arc, that you can't really see as red, but whatever, they would ask for arc ACB. The reason they include that C is because it's saying it has to go the other direction. And we can figure this out too with what we know. So how many degrees are in a circle? 360. Well, we know from here to here it's 100 degrees. So how much is left? What do we got to do with that 360 and 100? We have to subtract. So we have our 360 minus 100. That would give us this entire red arc is 260 degrees. Sorry, my markers are all dying right now, so I'll fix it eventually when I can. So the big things to remember is you can manipulate the circle with what you already know about degrees and whatnot, and to know that the central angle, if we're going from the inscribed angle and the central angle, it's all about 2's. Either you multiply 2 if you're going from inscribed to central, you multiply by 2. If you're going from central to inscribed, you divide by 2. And every single time you have to get the central angle, and that central angle tells you that arc length. So we're going to be doing a bunch of practice with this week. Sorry that you can't see a lot of this because I'm fighting with my markers. But I hope you have a super good day. I hope that if you watch this, I also see you in class. We'll see, because whatever. All right, so have a super good day.